Hello students, I am Ekta. Children, numbers everywhere. Do you have a phone at home? How many digits its dial have? What is the pin code of your locality? How is it useful? When you park a vehicle, do you get a token? What is its purpose? Have you handled 24 karat gold? How do you decide its purity? How high is the power of your spectacles? How much water does the overhead tank in your house can hold? Does your friend have a fever? What is his body temperature? You have learned about many types of numbers so far. Now is the time to extend the ideas further. Learning outcomes. To know that there exist infinitely many rational numbers between two given rational numbers. To represent rational numbers on the number line. Keywords from this lesson: number, positive numbers, negative numbers, natural numbers, whole numbers, rational numbers, irrational numbers, and integers. Rational numbers. When you want to count the number of books in your cupboard, you start with 1, 2, 3, and so on. These counting numbers 1, 2, 3 are called natural numbers. You know to show these numbers on a line, see below figure. We use n to denote the set of all natural numbers. N is equal to 1, 2, 3 and so on. Suppose there are 5 books in your cupboard and you remove them one by one. The number of books diminishes step by step. You remove 1, it becomes 4. Remove 1 more and it becomes 3. Again 1 more is removed, leaving 2. Once again remove 1 and you are left with 1. If this last one is also taken out, the cupboard is empty since no books are there. To denote such a situation, we use the symbol 0. It denotes the absence of any quantity. Thus, to say there are no books, you can write the number of books is 0. Including 0 as a digit, you can now consider the numbers 0, 1, 2, 3 and so on and call them whole numbers. With this additional entity, the number line will look as shown below. We use W to denote the set of all whole numbers. W is equal to 0, 1, 2, 3 and so on. Certain conventions lead to more varieties of numbers. Let us agree that certain conventions may be thought of as positive denoted by positive sign. A thing that is up or forward or more or increasing is positive, and anything that is down or backward or less or decreasing is negative, denoted by negative sign. For example, if I make a profit of rupees 1000 in my business, I would call that plus 1000, and if I lose rupees 5000, that would be minus 5000. Why? Similarly, if a mountain base is 2 km below sea level and its peak is 3 km above sea level, then the altitude of its base is minus 2 and the altitude of its peak is plus 3. What is its total height? Is it 5 km? With this understanding, you can treat natural numbers as positive numbers and rename them as positive integers. Thereby, you have enabled the entry of negative integers minus 1, minus 2, minus 3 and so on. Note that minus 2 is more negative than minus 1. Therefore, among minus 1 and minus 2, you find that minus 2 is smaller and minus 1 is bigger. Are minus 2 and minus 1 smaller or greater than minus 3? Think about it. The number line at this stage may be given as follows. We use Z to denote the set of all integers. Z is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Draw a copy of the above figure, hold your whole number, line up to a mirror on 0. You will see the natural numbers reflected in the mirror. The reflected numbers attached with a minus sign are negative integers. So the numbers to the left of 0 are negative and the numbers to the right of 0 are positive. But 0 is neither negative nor positive. 0 is just 0. It's non-committal. When you look at the figures above, you are sure to get amused by the gap between any pair of consecutive integers. Could there be some numbers in between? How did you draw the number line N above figure initially? Draw any line and mark a point 1 on it. From 1, choose another point on its right side at a preferred unit distance and call it. Repeat this as many times as you desire. To get W above figure, from 1, go 1 unit on the left to get 0. Now, Z is easier, just repeat the exercise on the left side. You have come across fraction already. How will you mark the point that shows 1 by 2 on Z? It is just midway between 0 and 1. In the same way, you can plot 1 by 3, 1 by 4, 1 by 5, 3 by 4, etc. You may find that many different fractions are shown by the same point. Can you say why? Will 5 by 4 and 10 by 8 be represented by the same point? Do you think 7 by 9 and 35 by 55 represent the same point? You will now easily visualize similar fractions on the left side of 0. These are all fractions of the form a by b, where a and b are integers with one restriction, that b is not equal 0. Why? If a fraction is in decimal form, even then the setting is the same. Because of the connection between fraction and ratios of lengths, we name them rational numbers. Here is a rough picture of the situation. A rational number is a fraction indicating the quotient of two integers excluding division by 0. Since a fraction can have many equivalent fractions, there are many possible names for the same rational number. Thus, 1 by 3, 2 by 6, 8 by 24, 8 all denote the same rational numbers. Denseness property of rational numbers. Consider AB, where A greater than B and their AM arithmetic mean given by A plus B by 2. Is this AM a rational number? Let us see. If A is equal to P by Q, P and Q integers and Q not equal to 0. B is equal to R by S, R and S integers and S not equal to 0. Then A plus B by 2 is equal to P by Q plus R by S by 2 is equal to PS plus QR by 2QS, which is a rational number. We have to show that this rational number lies between A and B. A minus A plus B by 2 is equal to 2A minus A minus B by 2 is equal to A minus B by 2, which is greater than 0 since A greater than B. Therefore, A greater than A plus B by 2, and that is equation number 1. A plus B by 2 minus B is equal to A plus B minus 2B by 2 is equal to A minus B by 2, which is greater than 0 since A greater than B. Therefore, A plus B by 2 greater than B, and that is equation number 2. From 1 and 2, we see that A greater than A plus B by 2 greater than B, which can be visualized as follows. Thus, for any two rational numbers, their average by midpoint is rational. We can repeat this process indefinitely to produce infinitely many rational numbers. Example, find any two rational numbers between 1 by 2 and 2 by 3. Solution 1. A rational number between 1 by 2 and 2 by 3 is equal to 1 by 2 into 1 by 2 plus 2 by 3 is equal to 1 by 2 into 3 plus 4 by 6 is equal to 1 by 2 into 7 by 6, that is equal to 7 by 12. A rational number between 1 by 2 and 7 by 12 is equal to 1 by 2 into 1 by 2 plus 7 by 12 is equal to 1 by 2 into 6 plus 7 by 12 is equal to 1 by 2 into 13 by 12, that is equal to 13 by 24. Hence, Two rational numbers between 1 by 2 and 2 by 3 are 7 by 12 and 13 by 24. There is an interesting result that could help you to write instantly rational numbers between any two given rational numbers. Result: if P by Q and R by S are any two rational number such that P by Q less than R by S, then P plus Q by R plus S is a rational number such that P by Q less than P plus Q by R plus S less than R by S. Let us take the same example. Find any two rational numbers between 1 by 2 and 2 by 3. Solution 2. 1 by 2 less than 2 by 3 gives 1 by 2 less than 1 plus 2 by 2 plus 3 less than 2 by 3, or 1 by 2 less than 3 by 5 less than 2 by 3 gives 1 by 2 less than 1 plus 3 by 2 plus 5 less than 3 by 5 less than 3 plus 2 by 5 plus 3 less than 2 by 3, or 1 by 2 less than 4 by 7 less than 3 by 5 less than 5 by 8 less than 2 by 3. Solution 3. Any more new method to solve this? Yes, if decimals are your favorites, then the above example can be given an alternate solution as follows. 1 by 2 is equal to 0.5 and 2 by 3 is equal to 0.66 and so on. Hence, rational numbers between 1 by 2 and 2 by 3 can be listed as 0.51, 0.57, 0.58. Solution 4. There is one more way to solve some problems. For example, to find 4 rational numbers between 4 by 9 and 3 by 5, note that the LCM of 9 and 5 is 45. So, we can write 4 by 9 is equal to 20 by 45 and 3 by 5 is equal to 27 by 45. Therefore, 4 rational numbers between 4 by 9 and 3 by 5 are 21 by 45, 22 by 45, 23 by 45, 24 by 45 and so on. Points to remember. A rational number is a fraction indicating the quotient of two integers excluding division by 0. The connection between fraction and ratios of length, we name them rational numbers. A rational number can be expressed as either a terminating or a non-terminating recurring decimal. A rational number can be expressed as either a terminating or a non-terminating recurring decimal. When the decimal expansion of P by Q, Q is not equal to 0, terminates, that is, comes to an end, the decimal is called a terminating decimal. Thanks for watching. Like, share and subscribe.